Hello everyone. So welcome to the next lecture. So here I am resuming the consensus algorithm. So in the last lecture I discussed proof of work. So just to review a bit, what proof of work does is, so the miner collects the transaction which is there in the blockchain network, and he forms a block in which the different transactions collected from the blockchain network is collected, and from that transaction the miner tries to find the valid block hash value. And I discussed in the previous lecture that the previous block hash value is determined using the Merkle root, which is calculated through the hash values of the transactions which are collected by the miner, and the previous block hash value and the nonce. So the main task of the miner is to find the block hash value which is satisfying the challenge posed by the blockchain network. So the miner has to find the block hash value which has a certain number of zeros in the leading bits. So the number of zeros in the leading bits is decided as a challenge by a blockchain network. So for that, the miner has to have the sufficient computational facility so as to find a valid block hash value. So the different miners present in the blockchain network, they are in competition among themselves to find the valid block hash value. And once a miner has calculated the valid block hash value, he propagates the valid block to the other miners. And as per the proof of work consensus algorithm, all other miners have to accept that block as it is a valid block, because the miner was able to find the valid block hash value as per the challenge posed by the blockchain network. Now, this proof of work has two main drawbacks. One is that simultaneously many miners are in competition among themselves to find the valid block hash value. For that, they have to have the computational power, and to execute that computational power, all the miners have to spend lots of electrical energy. So as the miners are simultaneously trying to find the valid block hash value, so you can imagine lots of electrical power or electrical energy is being wasted. So this is one of the major drawback of this proof of work consensus algorithm. Another major drawback of proof of work consensus algorithm is that there can be a monopoly in the blockchain network, in the sense that a miner who has good amount of computational power, he stands high chance to find the valid block hash value. And as we know that a miner is rewarded for finding the valid block hash value. So in this way, it may create a monopoly. So to improve over it, another consensus algorithm was proposed, which we call it as proof of stake. So as the name sounds, the miners who want to participate for mining the block, they have to stake something. So what they stake is, they stake the tokens or the cryptocurrencies to the blockchain network. Now, what this stake value has to do with the miners? So to understand that, let us look at this bit of calculation. So here we have validator A, validator B, validator C. You can understand that we have three miners: miner A, miner B, and miner C. Miner A or validator A, let us say, has staked 100 tokens, and miner B or validator B has staked 200 tokens. Validator C or miner C has staked 700 tokens. So the probability of validator A to get selected for mining the block is 10%. So how we find this probability? So total staked tokens are 1000. So simply it is 100 by 1000 to find the probability of validator A to be selected. So it's not that the validator C, who has staked highest number of tokens, gets selected always, but he gets higher probability to be selected. So the difference between this proof of stake and proof of work is that in proof of stake we don't have the miners simultaneously mining the block. So it is the miner who gets selected, he only mines the block. So every time the election of the miner is done, the miner is selected as per the probability. So the miner who has highest number of tokens staked or cryptocurrency staked has the highest chance of being getting selected. Another good point of this proof of stake, if I compare with proof of work, is that here, suppose again, if I come back to this slide, suppose um, if I have validator A selected at one time and validator C selected at another time. What happens that uh, the the challenge posed by the blockchain network is easier for validator C as compared to validator A, simply because, as I told you, the challenge that blockchain network poses to a validator or a miner is to find a valid block hash value which has some leading number of zeros. So the target value or the challenge posed by the blockchain network, one can find that it is given by this formula. So you see, SHA256 is nothing but it is a calculated block hash value which is calculated by hashing the timestamp, previous hash value, and nonce value, and as per proof of stake, it is it is less than the target into coin. So let us say if the blockchain network has challenge posed, that the miner has to find the leading bits which are 0 to be 6 leading bits. Now if I go to validator C, right, validator C has staked 700 coins. So this target value into 700 coins, so it automatically reduces the leading number of bits which has a certain number of zeros. And similarly for validator A, the target is multiplied by number of tokens staked by validator A, which is 100. So definitely that the challenge for validator A will be more than validator C. So there are two good points in this proof of stake as compared to proof of work. Here, only one miner mines the block at a time, unless proof of work where many miners are trying to validate the block at the same time. So this automatically saves the electrical energy. Another point is that once a validator is elected to mine the block, the challenge that the miner has to fulfill is determined by the coin or the tokens the miner has staked. So higher number of tokens the miner has staked, and if he gets selected, then the challenge reduces. And what is the advantage of the reduced challenge? That the block gets mined very fast, and this has a direct connection to throughput of the transactions. Throughput of the transactions means how fast the transactions are getting validated. So this is one of the bottlenecks in case of blockchain network. So if you compare the money transaction platforms like the traditional money what to say money transaction systems, they have good transaction throughput, means there the transactions getting validated are very fast. But in blockchain network, the validation of transactions is very slow, because it is directly to do with this consensus algorithm. Like in proof of work, many miners are trying to mine the block, they are trying to find the valid hash value, which is as per the challenge posed by the blockchain network. So to fulfill that challenge, it takes a lot of time for a miner to mine a block and hence to validate the transaction. But with proof of stake, only one miner mines the block, and the challenge is subsequently reduced if the number of tokens staked by the miner is high. So the miner is able to mine the block quite fast. So this is the another additional advantage of proof of stake, that the transaction throughput or the number of transactions getting validated per second is increased. So Another type of consensus algorithm we have is proof of authority. Now, this proof of stake, again, one can say that uh, it has also some sort of demerit, because if you see that a miner who has staked good amount of tokens, then he will have very high chance of getting selected to mine the block. So this is again creating a sort of monopoly. So the proof of stake consensus algorithm is again monopolizing the block validation system in blockchain network. So to overcome this further, proof of authority consensus algorithm was proposed. So in proof of authority algorithm, one can say that there is no discrimination in terms of the getting selected, which is proportional to the amount of tokens staked. So the probability of getting selected is not depending on the number of tokens or coins that has been staked. So here the miners who want to participate to be as miners, they definitely stake coins, but they all have equal probability of getting selected. And once they are selected, they have to mine the block, and they have to mine the block as per the same concept of finding the valid block hash value. But uh, one important thing in proof of authority is that there is an equal probability of every miner being selected, but they get something known as honesty points, or we say that reputation points they gain for every time they have a valid block mined. So the miner which has a large number of reputation points, he gets higher probability of getting selected. So this is a much fair system as compared to proof of stake. Now, I will come to a very interesting concept in blockchain network, which is known as forking phenomena. To understand this forking phenomena, let us look at this diagram. So in this diagram, we see T1, T2, T3, T4, T5. So these are the time instant. So let us say in time instant T1, some miner mines a block which we call it as block 1. And in time instant T2, let us say two valid blocks are mined, that is block 2 and block 3. It may happen, it may definitely happen that two miners may find valid blocks at exactly at same time, but it happens rarely, but it may happen. So now, since both the blocks are valid, they have equal right to be added in the blockchain. So so which block has to be added to block 1? It should it be block 2 or should it be block 3? So the miners who mine block 2 and block 3, both the miners, they propagate block 2 and block 3 in the blockchain network. So block 1 is already present in the blockchain network, which was already mined. So other miners who collect block 2 or block 3, they have they what they do is they randomly connect block 2 or block 3 to block 1. So let us say some miners connect block 3 to block 1 and some miners connect block 2 to block 1. So there are two blockchains which are revolving in the blockchain network among the miners. One blockchain consists of block 1 and block 2. Another blockchain consists of block 1 and block 3. Now let us say in time instance T3, three blocks are mined simultaneously: block 6, block 5 and block 4. Again, since these three blocks are valid, they have equal chance to be connected to the existing blockchain. So now there are two blockchains which are existing. One is block 1, block 2, and another chain consists of block 1 and block 3. So again, the miners which are holding these two blockchains, they may connect block 6 or block 5 or block 4 to either of these blockchains, right? So now if you observe at time instant 2, a fork is created. Fork means there are two blockchains which come into picture. That is block 1, block 2, and block 1, block 3. So this fork, we call it as fork. This come into picture when two or more blocks they are validated at same instance. So now we have three blockchains at time instant T3. We have three blockchains existing in the blockchain network. One is block 1, block 2, block 6, block 1, block 2, block 5, block 1, block 3, and block 4. So let us say now in time instance T4, a block is mined, which is block 7. And let us say some miners, they connect block 7 to block 5. Now let us say at time instant T5 we have block 8 mined. Now to which blockchain block 8 should be connected? So the rule says the blockchain which is longest to that block 8 should be connected. So longest blockchain among the three is block 1, block 2, block 5, block 7, and block 8. So that becomes the longest blockchain, and this blockchain is finally accepted by all the miners, and the other blockchains become orphan, or we say redundant, right? And they are we call it as uncle blocks, right? So this result because of this fork. So again we understand this fork is created in blockchain. So it is sort of a bifurcation that takes place. It is mainly because of valid blocks getting mined at a same instance. So it is a very important concept in blockchain network. So I thank all. Today I will stop here. In my next lecture, I will start with a very important concept of cryptography. I will introduce cryptography, and it has a very important role to play in the blockchain network. Thank you all.